Hey students, this is just try to show you hyperbolic, tangent, sine, cosine, like these, and we're going to show you how the mathematically this is calculated. The hyperbolic is functions. These are typically generically used in math class. Let me use a different pen to show you, just probably it's easier to read it. The hyperbolic, the functions similar to the regular functions that we have. Let me just show you the regular functions. Suppose you have a sine of x, and that's sines of x, which we have here. And sines of x can be expanded in terms of the use the exponential. Let's say sine x, and like these ones, or sine negative ix. And I referring to the complex number in the simple self, and x is just any variables which we have, and we can convert the sine x to the e to the to use exponential like these ones to calculate. Let me show you how we do that. First of all, just realize e to the I x, and this is just written cosine xi sine x. So this is the plus sign. So this, the reason we have plus sign is because the I in front of I we have a positive. If we have a negative ones, we have a negative terms comes out, minus I sine x. And this kind of things which we call identity, they are exactly the same. And you actually can use a calculator to calculate this. There will be no difference in this case. Now let's see whether we can find out from these two functions. And you can see if you have equation number 1, here's equation number 2. If you add them up, you're going to subtract these each other, so you get a cosine. But if you subtract them, let's do 1 minus 2, and you will see my left hand side e ix minus e negative ix. My right hand side, when you do the subtraction, these cosine terms gone, and this becomes 2i sine x. So then you can see my sine x just equals eix to the ix and e to the negative ix divided by 2i. So this is the regular sine function which we have. Now hyperbolic function is similar to this, except that we write it differently, and in this particular fashion. And we will change this I, remove this I and remove this I there, and we change this cosine cosh and sine cosh. They are just almost exactly the same. That's what you have. So here, if you have a hyperbolic sine x, and this just equals e to the I, this I removed, x minus negative x divided by 2. So all these i's will be removed, and this u representing so-called sine hx. And that's it. You can do the same thing with the cosine. Cosine x, regular cosine x, is eix plus negative ix divided by 2. And then here's the hyperbolic ones, just remove this I. Everywhere remove this I, so you get I plus e negative x. So these two. And you can do the tangent as well. So tangent will be, hyperbolic tangent will be like this. Sine divided by cosine, so eix negative I, ex plus e to the negative x. That's hyperbolic. And that's the sine. You can do the tangent as well. So in this case, tangent will be, let me over here, tangent, regular tangent x just equals this term divided by that term. So this I will be remaining, so you have I in the denominator, and the numerator x minus e to the ix. And so that's what you get, and you have another term, eix plus negative ix. So that would be, that's what you get. Essentially what we are doing here is we convert sine or cosine to the exponential functions. And so exponential function, but you need to remember this is the imaginary part of I, and this is the negative imaginary part I. But when you have a hyperbolic, we remove these imaginary ones, so this would be hyperbolic sine x, and sometimes somebody calls cosh, sinh, tanh, whatever. I normally don't care whatever you call them, but it's just e to the x and minus e to the x. So now you see this term, that term are exactly the same, and that's it.